Dependency injection brings with it many advantages that make applications easier to maintain and evolve. Benefits include promoting the loose coupling of components and the use of abstractions, both of which ensure that low-level code changes don't propagate up to higher-level code. Using dependency injection also supports improved testing by allowing unit tests to inject mock or fake dependencies, and it helps us to improve the readability and the cleanliness of our code. Remember that amazing weather forecaster we created earlier? It also implemented the iWeather Forecaster interface. Now that we're using dependency injection, it's easy for us to swap out the implementation type resolved at runtime simply by updating the service registration. We can change the implementation type for this service registration, and we don't need to touch the index model because it still depends on an iWeather Forecaster abstraction. I'll start the application by pressing F5. When the iWeather Forecaster is resolved, the amazing weather forecaster service is now injected into the index model for the home page. I can refresh this page several times, and the weather remains sunny every time. A single change like this to our service registration conveniently takes effect throughout the whole application for any code depending on iWeather Forecaster from the container. A second benefit is that the index model is now easier to test. This code fails to compile because the index model no longer has a default parameterless constructor. To fix these tests, let's create some fake weather forecaster implementations for use during testing. We could, of course, use a mocking framework here, but because the interface is so simple, we can implement it ourselves. The first implementation will return a fixed weather result, where the summary always returns sun as its value. We can copy this fake and make one that always returns rain as its summary value. For the test that asserts on the sunny description, we can now pass in a new instance of our sun forecaster fake. We also need an iLogger argument for this constructor. Fortunately, Microsoft has us covered, and we can use a null logger of index model here, accessing the static instance. This test now compiles. We can repeat this for the rain test, passing in the rain forecaster fake. I will now run the test from the test menu, and they both pass. Due to our changes, we're now able to successfully run these unit tests and adequately test the logic of the index model. Because of our refactoring, we can manually provide dependencies using fakes, mocks, or stubs during testing. This is a valuable advantage of inverting control with constructor injection, combined with depending on abstractions rather than concrete implementations. In the next module, we'll learn more about the Microsoft Dependency Injection Container.